Okay, graphing proportional relationships and calculating unit rate. This is pretty much the same as slope. We're going to be using the same formula again, and we're going to look at proportional graphs while we're also looking at unit rate on those graphs too. So one thing about the proportional relationships, our slope-intercept is this. On your formula charts, once we start kind of looking at those, you're going to have this formula. It looks like y equals kx. And it means the same thing. This and this are the same. Okay, it represents the slope. This one is usually more so talking about constant rate of change or unit rate. But again, like I said, it's all slope. So number one, Ethan recorded the height of a tree he planted from a seed at different time intervals. His data is shown in the table below, and we have to find the unit rate. So I'm going to do the same thing I would if I was finding slope. I'm going to see how much it's changing by. And in tables, if it's not labeled, just know that the left side is always x and the right side is always y. And so we can label our points the same as we normally would. I have x and y. X and y. It's my 1s and my 2s. So I'm going to solve it the same way. So 9 minus 3 and 6 minus 2. So 9 minus 3 is 6. 6 minus 2 is 4. And so if we divide those, I get 1.5 as my unit rate. And on these, we are not looking for y-intercept. We're just looking for positive or negative unit rate or slope. Okay, and what that means is that's how much it's changing by. It's technically 1.5 over 1. Okay, so it's changing by 1.5 feet every 1 year. If you wanted to get technical, that's what it means. Number 2, Drew recorded the height of a giraffe from the time it was born at different time intervals. So we have x and y, same thing. I'm going to pick the two smaller numbers, and I'm going to use the slope formula. So y2 minus y1, x2 minus x1. So I've got x1, y1, x2, y2, and I'm going to set this one up, and you can solve it. 12.5 minus 5, 5 minus 2, get your answer, and then you'll divide those. So when we're looking at graphs, number 3, a water hose discharges water at a rate of 45 gallons per minute. So that's basically saying 45 gallons every 1 minute. Which graph has a slope that best represents this rate? So if it's 45 gallons for 1 minute, when we're looking at these graphs, that's what we want to find. We want to find those 2 points on our graphs. So since our x-axis is talking about the minutes, we want to find 1 on each graph. And where that 1 is, our slope line should be crossing at around 45. So F seems to work. H, the problem with H is it's a rate. So it's going up by 45 gallons every single minute. So for this grade and for the slope and the unit rate that we look at, you will not see one like this, especially if it talks about a rate and increasing by this much per minute or per hour or per day, or it's talking about something increasing or decreasing. You will never see this graph. Okay, you'll see a slanted line. On G, under 1 minute, my line crosses at about 15, and it's supposed to be 45. So this one's out. And on J, at 1 minute, it crosses at about almost 60. It's close, but 45 is right here. Okay, and so that is not on the line, so that one's not going to work. So it would have to be F. Same thing on number 4. Leonore pays a total of $16.50 for every 6 shirts she has dry cleaned. So on this one, luckily we have 6 on our graph, and so we can find where 6 is and see which graph shows us our line crossing at $16.50. Another way that you can do that is it's always the change of y over the change of x. That's what we do when we find slope. We subtract the y's, we subtract the x's on the bottom. So if it's $16.50 for the y and 6 for the x, if you just straight up divide that, you get 2.75. And sometimes that can help, sometimes it doesn't help. Luckily, we have 6 on our graph. If we did not, if our graph was a little bit shorter and only showed us maybe 1 through 4, we might need to know that is our unit rate. It would be this over 1. So for now, let's look for 6 and $16.50. So where 6 shirts are, it should be at about $16.50, so right over 15. So that one seems to work because it's right above 15. H should be about right there. My line does not cross that point. On G, same thing. My line should be crossing about right there. It does not. And with J, it's crossing way high up. It's not going to cross the point I need it to cross at. So F is going to be my answer. Number 5, an aquarium is being filled with water. Which statement best describes the rate of change for the situation? 2 ways we can do this. Since our answer choices are looking at per second, that means per 1 second is what that really means, right? So if we look at the 1 second mark and see where our line crosses. So if it's between 0 and 5, it should be 2.5, which should be D. Just to double check, because sometimes that might not always work. So another thing that we can do is we can find 2 points, and I'm going to use 0, 0 because it's easy. And I'm going to use 5 and 2. So I'm going to use this other point. So I'm going to use 2 and 5. And I'm going to label them XY, XY, 1s and 2s. So my y's, I've got 5 minus 0 and 2 minus 0. So 5 over 2. And when I divide 5 divided by 2, I get 2.5. So same answer, 2 different options. Number 6, a tree in Dante's neighborhood grew 18 inches in the first 2 years after it was planted. So at 2 years, which seems to be my x-axis, my line should be crossing at 18. So I've got 2, 2, 2, and 2. Remember, graphs like this are not going to work for us right now. Not when it's talking about something that's growing, increasing over time. So my line should cross at 18. Let's see, our line crosses about right there, which is not quite 18. So let's check number, or G. Okay, that one's pretty close. And this one, it's hard to tell, but probably about right there. So which of those matches what the problem had said? Same thing on this one. There's 3 adults for every 45 students, which graph models a relationship with the same unit rate. So from what I can tell, it looks like our our y-axis is talking about adults, and our x-axis is talking about students. So where my 3 is, my line should be crossing at around 45, which would be somewhere here in the middle. So if I look at F At 3 and 45, that's where my line should be crossing, and that one is not. That one seems to work. Remember, we're not looking at those right now, and that's where my point would go. So which of those is on the slope line? Number 8, the rate of change. So we're going to find 2 points. Remember, rate of change, same as slope. So we're using that formula, y2 minus y1, x2 minus x1. And because I can, I'm going to use 0, 0 because it's there. And I'm going to use this 2 and 10. So I have 0, 0, 2, and 10. And we're going to label them. Remember, it's always x and y. My 1s and my 2s. So I have 10 minus 0, and I have 2 minus 0. Last step, you're going to divide those two numbers and get your slope. Two points I have 0, 0. And this is the only other point I see that I can use. So 4 and 30. So x, y, x, y. Use your formula to find your slope or rate of change. Same thing on this one, unit rate. Same thing as slope. 0, 0, and I'm going to use 236 also. Or you could even use 1, 8, and 18 just to mix it up. You could do that too. So 1, 18, 2, and 36. So x, y, my 1s and my 2s. Use your formula and plug those numbers in. And then divide. On this one, you're just finding the slope or the unit rate. And on a table, remember, this one's always your x value, this one's always your y. So you can label them x, y, x, y. This can be my 1s, my 2s. So set it up the same way. 31 minus 30.50, and then 10 minus 5. Whatever you get when you divide is your slope. This same thing as the last one, except our table is on its side. And when our table's on its side like this, the top row is our x value, bottom is our y. So it looks a little bit different. So when we label, just remember you've got x1, x2, they're right next to each other, y1 and y2. But the same formula we're going to use. Same thing, 350 minus 250 and 3 minus 1. Same thing on this one, pick whichever two you want and use your formula. y2 minus y1, x2 minus x1. If you're doing this online, you can always rewrite it on a piece of paper if you need to. Sometimes it gets a little confusing just doing it on the calculator. Slope and the y-intercept on this one. So your y-intercept is 0, and that's a number, that's a point I'm going to use for my slope. And then we've got 13, or 2, not 13, 2 and 30. Okay, so your y-intercept, you've got 0, it's going through 0. And then I would use these 2 points to find the slope. So on the scientific notation, it's a little bit different on Schoology. So, but just as a refresher, to write this number in scientific notation, you put your new decimal after the first non-zero number. So that would be right here. So when I'm writing in scientific notation, the first part of it would look like this, 1.8 times 10. And now I'm going to move this new decimal. I'm going to count all the way to the end of the number. So that's 1, 2, 3, 4, 5, 6, 7. So since I counted to the right, and since it's a big number, it starts with digits that are not 0, it's a positive exponent up here. So the way you would write that is in the first drop-down box is going to be your decimal, so that was 1.8. The times 10 is already there. Now you have to tell me if it's a positive or negative exponent. So in this case, it's positive, and our exponent is 7. Okay, so those are your 3 ways, or your 3 answers technically for these scientific notation answers. Okay, on this one, same thing. I want to put my new decimal after the first non-zero number. So if I'm looking, 8. That's my first non-zero. Okay, now I'm going to count backwards, okay, because I want to get back to the decimal over here. 1, 2, 3, 4, 5, 6. So my decimal is 8.92. And since I counted to the left, and since it's a number that started with a bunch of zeros, it's a negative exponent, and I counted 6 places. On this one, same thing. My new decimal is going after the first non-zero. So this negative is talking about the whole number. So when I write that down, it's actually going to be -3. Okay, and so from that new decimal, I'm going to count back to the old decimal. 1, 2, 3, 4, 5. So since I counted to the left 5 places, it's a negative exponent. Same thing like on the last one. Decimal goes here. It's a negative decimal. And since we're counting to the left, however many places you count, it's a negative exponent. Those are pretty self-explanatory. On number 20, your decimal goes here. You are going to write the whole decimal in that box, or choose the whole decimal.